In this video, we are going to continue our work with finding multi-step inverses. So the work here is not any more challenging than what we did before. It's just different functions, so we just need to talk through some additional examples. So here's our first one. We're going to find the inverse of x minus 3 over 15, all that whole quantity raised to the fifth power. Okay, let's talk through our steps. So step one, I know you've already written these a couple of times, but go ahead and write them up again at the top of your paper. The more you write them, the firmer in your memory they're going to get. I'm going to change f of x to y. Nothing else is going to change at this point. Okay, now step two. Step two is to swap the y and the x. So where I had a y, I'm going to put an x, and where I had an x, I'm going to put a y. All right, step three, and this is the step that we said would change depending on what your function was. This is where we're going to solve for y. So every time this one is going to be a little bit different depending on what the function is in front of us. So we basically want to look at what is the outermost thing that has been done. When you solve for y, you're basically undoing everything that's been done to it. So I want to look at the outermost function first, which is raised to the fifth power. So what is the opposite of raised to the fifth power? Well, that's going to be the fifth root. So I'll take the fifth root of both sides. Raising something to the fifth power and the fifth root are inverses of each other. They cancel one another out. So I'm going to have the fifth root of x equals y minus 3 over 15. Okay, now do you guys remember what did we do when we had a fraction? How did we clear out that fraction? Well, we multiply both sides by the denominator. All right, so now I've got 15 times the fifth root of x. That 15 is outside of the fifth root, so it has to stay outside. I can't move it inside and multiply it by the x. It has to stay outside because it is not a fifth root itself, it's just a 15. On the right-hand side, the divided by 15 and the multiply by 15 are inverses. They cancel each other out. All right, still working to get y by itself. That last step is going to be to add 3 to both sides. And I'm going to do that without writing out the plus 3 because I'm running out of space. All right, so there I have solved for y. And then my last step, just like before, replace y with f inverse x. So I'm going to say f inverse x equals 15 times the fifth root of x plus 3. All right, and you remember if you were to graph those, they would be reflections of each other across the line y equals x. So if I put this one in my calculator as y1 and I put this one in my calculator as y2, I should see them reflecting each other across the line y equals x. All right, let's do another one. All right, this time I've got a 1/4 power, but that's okay. We worked with fraction exponents last time, not worried. All right, so first thing we're going to do is replace y with f of x, or replace f of x with y. Okay, all right, now that second step, no difference here. Swap the x and the y. So I'll do just like I did last time and swap those two. Okay, now, oops, grab the wrong thing. I'm going to solve for y. Okay, so let's see what we've done here. Remember, we're going to undo whatever's been done to y. So the last thing that was done to y, or the outermost thing, is going to be this plus 7 right here. So I'm going to subtract 7 from both sides, working to get y by itself. Okay, now look at this. Do you see that 1/4 is only attached to the y? It doesn't have anything to do with the 5. So I can divide both sides by 5. Now I can choose to do it as one fraction if I want to, or I could choose to do it as two separate, one 5 underneath the x and a separate 5 underneath the 7. Okay, so now I've got y to the 1/4 power. You remember what I want to have here is y to the understood 1 power, and when I raise a power to a power, I multiply. So I know I'm going to raise both sides to some power. So let's remember from our last video, 1/4 times what is going to be 1. Do you remember what we multiply by? we multiply by the reciprocal. So you just take that fraction and flip it over, and when you multiply straight across in the numerator and denominator, you're going to get 4, and 4 over 4 is that 1 that I want. So I will raise both sides to the 4 over 1 power. Now 4 over 1 is the same thing as 4. So I'm going to raise both sides to the 4th power. The 1/4 power and the 4th power, 1/4 times 4, that gives me 1. So I'm just going to get plain old y. Y to the first and y are the same thing. And then on this side, I'm going to just leave all that to the 4th power. Remember, you cannot distribute this exponent because I have adding or subtracting inside the parentheses. In this case, it's subtracting. But anytime you have addition or subtraction, you cannot distribute the 4. So my last step, replace y with f inverse x. So my final answer, f inverse x equals x minus 7 over 5 raised to the 4th power. All right, let's try another one. Let's try this one. Okay, so this time I don't have boxes over those. I think we have talked through that often enough that we can just look at it now. So first step, put in my y. All right, second step is to swap my x and my y. Okay, now that third step where I'm going to solve for y. This is the one that changes every time depending on what I've got. Okay, so let's analyze this. What is the last thing that was done to y? What is the outermost thing we need to get rid of? Well, I can't add 3 right now because it's on top of the 5. And I can't do anything with this 4th root because the 3 and the 5 are both in the way. So the only thing that I can worry about right now, the only thing I can move is that 5. So instead of dividing by 5, opposite of divide is multiply. Multiply and divide are inverses. They cancel one another out. So I'm going to cancel those out right there. Okay, still working to get y by itself. Well, the 4th root is only on the y. It's not on that 3. So I'll add 3 to both sides, trying to get that y by itself. All right, so now I can get rid of the 4th root. Well, what's going to be the inverse of the 4th root? The 4th root and raising something to the 4th power are inverses. So I'm going to have 5x plus 3 to the 4th power. And because I'm running out of space, instead of writing a y right here, I'm going to go ahead and replace that with f inverse x. And I get this. So 5x plus 3 to the 4th power equals the inverse of what I had to start with. So now, can I distribute that 4? Can I raise both the 5 and the 3 to the 4th power? The answer to that is no, because I have a plus in the middle. I cannot distribute that. If I wanted to simplify it, I would have to write 5x plus 3 4 times and then FOIL that out and multiply and multiply. All right, let's try this one. The cube root of x to the 8th plus 4. Okay, so let's put in our y. Start off that same way. Swap the x and the y. Okay, now what do I need to do first over there on the right-hand side? Well, the first thing I'm going to need to do is get rid of that cube root. Both the y to the 8th and the 4 are inside the cube root, so I need to eliminate that cube root by raising both sides to the 3rd power. Cube and cube root are inverses. They cancel one another out. Okay, now what? Still working to get y by itself. I can see that that 8 is attached to the y, but not the 4. So I'll subtract 4 from both sides. And then the last thing I've got there is that 8th power. So the inverse of the 8th power is going to be the 8th root. Okay, normally we would put a plus and minus on this, but we're going to have a restriction on the domain, which means we don't need to do that. We're just going to have to do the positive part, even though both the positive and the negative are there. Because if we do the positive and the negative, it will no longer be a function. So that's why I'm restricting it with only the positive. And so that's going to be my final answer once I replace y with f inverse of x. All right, let's try this one. So let's see what we can do here. Put in my y. All right, now, I've got three things. I've got a square root, I've got a divided by 3, and I've got a plus 11. Which of those three things should I do first? Well, I'm going to need to take care of the minus 11 first. It's not affected by the square root or the 3. So I can subtract 11 from both sides. Oops, I forgot to swap my x and my y. Let's do that first. Now we'll subtract 11. Same reasoning. Okay, now what do you guys think we should do here? Should we get rid of the square root by squaring, or should we get rid of the 3? Well, the square root is not affecting the 3, so I'm going to multiply both sides by 3 to clear out that fraction, because multiply by 3 and divide by 3 are inverses. In this case, because I'm just multiplying, I can choose to distribute the 3. I could leave it on the outside if I wanted to. All right, what's the opposite of square root? Well, that's going to be square. So I'm going to square both sides. So 3x minus 33 squared equals y. Okay, so what do you guys think? Can I write this as 9x squared and then square the 33 over here? The answer to that question is no, because I have a minus in the middle. Remember, anytime you have minus or plus in the middle, you cannot distribute your exponent. So when I replace f inverse x, I am not going to square both of those. If I wanted to, I would have to write it 2 times, and then I would have to FOIL it. That's how I could get rid of that squared. I cannot distribute into the parentheses because I have a minus right there. All right, last one. Let's try this one. So let's put in our y. The 6th root of x. Okay, this time I'll remember to swap my x and my y. Okay, so now I'm going to solve for y. So looking at that, what do you guys think is the first thing I can move? Is it the -5? Is it the 6th root? Or is it the 15? All right, well, if you guessed we need to get rid of the -5, you are correct. So how am I going to get rid of that? That's -5 times, parentheses mean times. Opposite of times is divide. Right, multiply and divide cancel each other out. Okay, now what? Should I move the 6th root or should I move the 15? All right, I'm going to move that 15. Oops. Because that 15 is not affected by the 6th root, so I want to go ahead and move it to the other side. Okay, how do you think I'm going to get rid of the 6th root? That's the last thing I have to do. To get rid of a root, I choose to use a power. Exponents and roots are inverses of one another. 6th root and 6th power cancel one another out. Can't distribute, right? Because I've got that minus in there. And because I'm running out of space, I'm going to go ahead and replace my y with f inverse x. So there's the final answer, x over -5 minus 15 raised to the 6th power. Now that x over -5, you might see it written as -1/5 x. You might also see it written as -x over 5. These are multiple choice questions on Desmos, so you have to be able to recognize it in a variety of forms. So whether they choose to write it like this, or whether they choose to write it like this or like this, those are all the same thing. It doesn't really matter which one of those you have written on your paper. Just make sure you can recognize it with the ones that are on the screen.